Even with BIM and virtual construction becoming more advanced, many teams still struggle with efficiently modeling, coordinating, and creating fabrication outputs for reinforcing bars. At CadMakers, through the process of developing digital twins for construction, we've created smart, customizable, logic-based templates for almost every component of a building, including rebar. In this video, we'll demonstrate a column and beam rebar template that combines 3D volumes from the concrete structure and an Excel spreadsheet to define customizable specifications from the rebar schedule. Within the spreadsheet, we can specify the diameter of vertical bars and stirrups, the pitch, the hook angle, and much more, with each configuration receiving its own row in the Excel spreadsheet. Based on the concrete volumes, a wireframe is created for each rebar cage, including the vertical bars, stirrups, and lap joints. Running the script to generate the detailed geometry, we use the feature name to map each cage to a specification. While the tool is running, all the bill of materials and weights are automatically calculated with a 3D annotation generated for easy identification. This gives users the ability to precisely cost each project within a few clicks, and then further detail the model after you're awarded the project for planning and fabrication purposes, saving both estimation, detailing, and fabrication time throughout the entire project. This wireframe driver allows the user to input and adjust parameters to further modify the rebar cage, giving users the flexibility and control to easily make modifications during the clash detection and coordination process that we'll show later on in this video. We'll repeat this step for the beams on this level. Alternatively, if preferred, we can batch instantiate all the geometry for the beams, columns, and slab all at the same time. Using this data in automation, we're generating the detailed 3D geometry, shop drawings, and machine code to automatically bend each of the rebar using a rebar bending machine via an industry standard format called BVBS. Once we've generated the rebar using our automated templates, we can conduct clash detection directly in the same platform to avoid rebar conflicts. There are two methods for checking clash in the software. The first is to use the rebar interference command to quantify the number of individual rebar clashes there are. In this case, we see that there are over 5,000 clashes. The second method is using the Innovia clash detection tool to quantify the clashes between the cages. In either of these methods, we are not exporting any data to clash in another software, and therefore are able to make changes in real time during coordination meetings. Traditionally, BIM coordinators will meet weekly to bring their models together in a clash detection software, go through their clash list, identify what needs to be fixed, and then return to the office to make the changes. Only after returning to the coordination meeting the following week do they discover that the proposed change created a knock-on conflict and must re-coordinate to find another solution. This is a vicious cycle of BIM processes. With the capability to make changes live in the meeting, our project coordinators can test different options and get immediate feedback from all project stakeholders, enhancing buy-in from the trades and reducing overall lead time to resolving conflicts. After fixing this clash and rerunning the analysis, we see that we've reduced the clashes and we can move on to the next item in the list. After completion of the coordination, we can extract all the rebar information and export it to BVBS format, which is an industry standard file format that most rebar bending machines take as an input. With BVBS, we can leverage the existing work and coordination completed in the model to automate the manufacturing and production of rebar for this project, ensuring that what was modeled is what gets built. If you're interested in learning more about this solution and how you can implement it in your own process, please visit the link in the description below.